Hey everybody, welcome back to the anatomy video series. Today we're going to start the cardiovascular system. So we're going to introduce the basic functions in the beginning of the cardiovascular system and start talking a little bit about the heart. So let's go ahead and get this thing started. All right, everyone, welcome to the first video in the series covering the cardiovascular system. Let's go ahead and get started. First of all, let's talk a little bit about the general characteristics of our cardiovascular system. Your heart is the center of the cardiovascular system. We're going to learn that even though it's one organ, it basically it's a two-pump system. You have the right half of your heart is responsible for pumping blood to the lungs for reoxygenation, and the left side of your heart is responsible for pumping blood, oxygen-rich blood, to all parts of your body. The term in itself describes what the system is. Cardio means heart, vascular means blood vessels, so it is the system of the heart and blood vessels. In some older text and in some other circles, you will hear it referred to as the circulatory system, but I prefer cardiovascular because the word describes what we're going to see in the system. The heart is a hollow muscular organ that weighs about 11 ounces. It is roughly the size of your fist, probably just a shade bigger than your fist. If you make a fist and then wrap your hand around that fist, that probably is pretty close to about the size of your heart. I'll go ahead and switch the camera over and demonstrate what I'm talking about. All right, so what we're talking about when we talk about the size of the heart, and it's about the size of your fist. So if you make a fist, this kind of, make sure your thumb is out. Always make sure your thumb is out when you make a fist. So they're saying that this is about the size of your heart. Most of the time, your heart's going to be a little larger than your fist. So what I like to say is if you wrap your hand around your fist, that's going to be a little closer to the actual size of your heart. It probably is going to be somewhere in between your fist and your hand wrapped around your fist. I guess it all depends on the size of your hands too. So, but that just gives you a rough idea. And when we do get the sheep hearts out and start working on them, they are going to be pretty close to the size of our hearts for the most part. So hopefully that gives you a little visual to understand what I'm talking about. It will beat on average about 100,000 times a day. So that's in a 24-hour period. It will pump the equivalent of 1,000 gallons of blood. If it were a one-way pump in a 24-hour period, it would pump 1,000 gallons. Now, clearly, it's just recirculating all of the blood that is in our closed circulatory system. And it just keeps recirculating that same blood. But again, if it were a one-way pump, it would pump 1,000 gallons in a 24-hour period. And here's the statistic that I find amazing. If you add up all of the blood vessels in your body, which include all of the capillary beds, you would have over 60,000 miles of blood vessels in your body. Now, the overwhelming majority of those blood vessels are microscopic. So, you couldn't stitch them all together because they're smaller than the needle and thread that you would use to stitch them all together. But that to me is an amazing statistic. So for those of you who know, the circumference of good old Mother Earth is about 24,900 some odd miles. And, we can call it 25,000, what's 100 miles amongst friends? So about 25,000 miles to go totally around the globe. So that means there's enough blood vessels in each and every one of you to circumvent planet Earth more than twice. And to me, that's an amazing statistic. Well worth mentioning. So here is a picture I took of the bodies exhibit when we were in Chicago in the museum. And this is basically the skeleton and the blood vessels. What they did is they embalmed a body with a resin. They heated it up and they injected it into the blood vessels, and they filled this individual's blood vessels with that resin. And then as it cooled, they then dissolved the body in I don't know what kind of acid they used, but they dissolved it with a particular kind of acid that did not dissolve the resin. And so all that was left, all the soft tissue was gone. And then all that was left was the resin then that filled all the blood vessels. And this gives you an idea of the macro blood vessels, the ones we can see, not the micro, but the macro blood vessels in our body. And I mean, if you think about it, there's blood vessels everywhere, because if you cut yourself, you bleed. So there's blood there. There's a blood vessel. So there is a lot of blood vessels in your body, and you can see it. It very well outlines this individual's body. Location of the heart. The heart is situated obliquely between the lungs and is a component of the mediastinum. Hopefully we remember from the respiratory system that the mediastinum is a space that is in between the lungs and will house the heart, part of the trachea and bronchial tubes, the esophagus, and of course some of the major blood vessels. And again, the mediastinum is the massive tissue between the pleura of the lungs. And remember, the pleura is the membrane that surrounds and encloses the lungs. The visceral pleura is what encases the lungs, and the parietal pleura is what surrounds and lines the inside of the thoracic cavity. So we see here in the diagram the trachea, and we see some of the major blood vessels. This is the superior vena cava. It's going to be bringing oxygen poor blood from the top half of the body back to the right side of the heart. The aorta, this is the largest artery in the body, and it's going to be the jump off point for all arteries taking oxygen-rich blood to any part of your body. It is the main trunk. The pulmonary artery, this artery carries oxygen-poor blood to the lungs from the heart for reoxygenation. Obviously, then this is the heart. Now it will be divided. It will be divided in a line, goes through about like this into the right half and the left half. And then, of course, the mediastinum, which is that space between the lungs. About 2/3 of the mass of the heart lies to the left of the body's midline. The reason for this is the left ventricle is the largest chamber of the body, and it pumps blood to all parts of the body. All tissues that need oxygen are going to be receiving blood basically from the left ventricle. So it's the largest, it's the most powerful chamber of all four. It is shaped like a cone, about the size of your fist, 5 inches long and about 3.5 inches wide at its broadest point. And from front to back, it's going to be about 2.5 inches thick. And so at this point, reference my little video break where I demonstrated the size of your heart and your hand wrapped around your fist. Is basically, it's going to be somewhere in between your fist and your hand wrapped around your fist for most people. The heart is enclosed and held in place by a protective membrane called the pericardium. a structure designed to confine the heart to its position in the mediastinum, but allow it sufficient freedom of movement. Your heart never stops moving. It starts beating before you were born and will more than likely only stop once in your life. And that usually will be at the end of your life. It beats 24 hours a day, 365 days a year. It never takes a break. It works continuously every day, every moment of your life. The pericardium will prevent any friction that the heart may incur so it doesn't rub up against anything. There's a fluid inside there, keeps the heart nice and lubricated and protects it during its work life. The heart wall has 3 layers. Remember, epi means upon or on top of. That's going to be the external layer. We call it the epicardium. On the inside layer, a very thin layer, will be the endocardium. And then myo, I'm sure we all remember that myo is the prefix meaning muscle. The myocardium is the muscle layer, and that is going to constitute the bulk of the mass of the heart. The epicardium and endocardium are very, very thin. And when you talk about the heart and the tissue that is the muscular tissue, that cardiac muscle tissue, you're talking about myocardium. So we'll talk a little bit about those layers. The epicardium is a thin, transparent outer layer of the wall, which gives the surface of the heart a smooth, slippery texture, again, combined with the fluid inside the pericardium and the pericardium itself. The heart is very well lubricated, and we never have to worry about any friction damaging the tissue, the muscle tissue that is the heart. The myocardium constitutes the bulk of the heart, as I just said a little while ago, and is responsible for the contraction of the heart. And again, this is the heart muscle, the cardiac muscle tissue that is, when we talk about the heart, this is what we're talking about. It is responsible for contracting and successfully pumping blood through your entire vascular tissue, all 60,000 miles of it. The endocardium is a thin layer of endothelium overlying a thin layer of connective tissue. This is going to line the inside of the chambers of the heart. It lines the inside of the myocardium and covers the valves of the heart. Now we're going to find that there are 4 valves in your heart that prevent blood from going backwards. And they're basically one-way trapdoors. They let blood go through the way they're supposed to go, and they don't let blood flow backwards if they're working properly. And we'll talk more about the valves when we get there. The 2 upper chambers of the heart are called the right and left atria. Atria is plural for atrium. So if you talk about one individually, let's say we'll talk about the right atrium, then you use atrium when dealing with just one. If you're talking about both at the same time, we refer to it as atria. They are the receiving chambers. They receive blood from the large veins in our body that are bringing blood back from the body. Here we have a good view of the right atrium, the inside of the right atrium. And here we see the superior vena cava is going to empty blood, oxygen poor blood into that chamber. Down here below, we see the inferior vena cava. So we have superior vena cava and inferior vena cava, both of which are going to empty blood into the right atrium. And then the left atrium is over here. We don't get as good of a view of it in this particular diagram. Each atrium has an appendage called an auricle. It increases the atrium's surface area and basically it is kind of a small cap or a pouch, I guess you could call it, that's on top of the heart. When we get the sheep hearts out, we will have a much better appreciation, a better view of what the auricle is. and they're good indicators to tell you where each of the atria are located. Each atria is separated by a partition called a septum. We've seen this term before. We talked about in the respiratory system, the one that divides your nostrils is the nasal septum. Here is a wall of muscle that separates the two atria, and we call it the interatrial septum. Inter, of course, remember from the introductory unit, intermediate means in between two, so the interatrial means intermediate to the two atria, and it separates the right and the left atria. The two lower chambers are the ventricles. They are separated by the interventricular septum. Same terminology applies. Inter, of course, just to reiterate, is short for intermediate, which means in between. Ventricular, meaning the ventricles. So this septum is in between the two ventricles. Externally, a groove called the coronary sulcus separates the atria from the ventricles. And that is something that we're going to see on the outside of the heart. The anterior interventricular sulcus and posterior interventricular sulcus separate the right and left ventricles. And again, they're going to be markers on the outside of the heart that will allow us to determine whether we're looking at the right or the left half. The sulci, which is plural for sulcus, contains coronary blood vessels and variable amounts of fat. So all of your diagrams and your models won't show, a lot of them won't show the fat that's on the heart that will, they insulate those blood vessels that are feeding the heart wall, the heart muscle, that oxygen-rich blood. But when we get the sheep hearts out, you'll see it. And I will be sure to point that out. All right, that is probably going to do it for video lesson 1. As always, if we are on remote, then you're going to head on over to Schoology and find that exit slip. If you're home and watching this because you're quarantined or something, then there'll be no exit slip, but hopefully this will help you stay up to date on what we've been talking about in class. So as always, thanks for watching. If you have any questions, just shoot me an email, and don't forget, click like and subscribe. Talk to you later.